I'm Sjoerd Mulder. I'm the co-founder and CTO of Crobox, and I'm going to tell you something how we started in the summer of 2015, building our software product, and how it's evolved into the platform we have today. So, Crobox does persuasion as a service. Well, what does it mean? We use consumer psychology and machine learning to actually find the why behind the buy. So every person in this room is sensitive to a certain persuasion strategy or a persuasion principle. That could be scarcity. I mean, the Dutch are suckers for scarcity. It could be social proof. It could be authority. Germans are quite sensitive to authority. So Crobox tries to find which visitor on the website is sensitive to what message and actually presents that message. So how do we achieve that? It's actually quite simple. We collect click behavior on the website of our customers. We send that through our server. We build up persuasion profiles, and for each individual visitor, we try to figure out which properties are working best for that user. And then actually we send back to the website or to the user certain messages with the prediction on what to show. And how that would look like is like this small message saying must have. So you must have this product. I mean, you're immediately going to buy it. And other things that are certain promotions that we show is 2 people are checking out this product right now. So that, I mean, Booking.com is famous by all these messages, right? So it's our inspirational guidance almost, but actually we build up this product and build up these profiles to do that. So let's get started. Let's build it, right? So how do we start? Well, first we need a website, or we need a server, and we are going to add Nginx as load balancer for it. Simply because we have some static website things we have to host. We have some admin panels we have to host. That's it. So in order to get us started, back then, I was very comfortable with Spring, Java, Spring MVC. So just add Spring MVC to it, and we need a database. So what's the most popular database in the summer of 2015? MongoDB. Now you don't hear a lot of it anymore. So, right, 3 months, build it, ship it, go. So it went pretty well. First customers connected. But then, actually, we needed to scale it up. So especially Christmas period in 2015, we just added bigger server. The problem was, though, that we configured our system such a way that the Spring Boot thing could not really be replicated to multiple servers. That has all to do with also building up this persuasion profile. So you need to have, you need to make sure that every individual visitor is getting to the right visitor, but also abroad all the visitors for certain customers, we use statistics that also needed to be ended up in the same server. So it was quite hard to scale it up, but we could easily scale the database. So we added some more MongoDB servers and everything was going okay. But we had some challenges there, and that's actually one guy that's coming along every year, which makes the internet traffic double. And you have to imagine that we inject this Java, or we have a JavaScript running on each website of the client, and all the visitors on that website will send events to you. So it's like DDoSing yourself with events based on how busy it is on the website of the customer. And you cannot really control the website of the customer because they might send out a promotion or an email campaign, right? And it will also do a spike. Or Sinterklaas comes by, or actually a lot of people from Black Friday or Christmas are coming on the website, which will actually spike the traffic. So you have to make sure that you build out a system then that can handle that load. So let's see if it goes to the next slide, or maybe not. Right, so the challenge we had during this Christmas period in 2015 was that basically we didn't have automatic restarting of services that were going out of memory. So if the Spring Boot application would take too much memory, or the Java heap was exploding because there was too many sessions or visitors being kept in memory, it would out of memory, but then the server would not automatically restart. So we had a challenge there. We were still doing manual deployments using just command line interface. So we would log into the server, then actually say, okay, or SCP over the jar file to start, and then it would run. We also did analytics in MongoDB, and MongoDB it's a really nice tool, I think, if you don't do full table scans or do analytics based on the data set it has. So it's really well suitable for just read and writing some information, but if you want to do an analytics batch over it, it will completely lock up. So just a table scan, it will completely lock up for writes and for reads, other reads. So we had huge problems with getting our analytics on top of MongoDB. We had many servers, so we have multiple logs. You have logs everywhere. So if you then want to debug a problem, it's very hard. You look in the syslog, you look in the specific Tomcat log or the Spring Boot log, you have to look in the MongoDB log. I can't find the problem. Oh, maybe it's the kernel log, or because the kernel does something wrong. And it's actually hard to handle peak traffic. So I will explain, for each of these challenges, I will explain how we found a solution and actually where our platform grew to. So, well, the most simple solution for many logs and multiple servers is that there's this great tool called the Elk stack from Elasticsearch with Logstash and Kibana. And unfortunately, we found Kibana not really the right fit into searching through logs and actually setting up alerts through logs. So what we did is we used Elasticsearch and Kibana to ship all the logs to a central system, and then we used Graylog, which I think is it's really specifically built for logs. And with Graylog, we achieved a central logging place where we could send all our data and actually have aggregates over it and actually do searches. But the nice thing is that it also provided out-of-the-box alerts. So you could set up an alert saying, if I get more than 3 messages in the past minute that have the facility kernel and the level is error, then I want an email. So this way you are getting notifications of things going wrong in your system before actually you got end users complaining or you figuring out yourself that something is not really working. So another challenge is it's really hard to handle peak traffic. So how we solve this is actually by already splitting up the monolith Spring Boot application, which first was doing the event collection and the processing and the admin part, into 2 separate parts. So we actually built a Spray or Akka HTTP asynchronous collector, which only does give me the event from the HTTP interface, and I put it on Kafka. That's the only thing. Well, there's some deduplication in there, but that's the only thing. And actually that really helped us handle peak traffic. So we could now send thousands of events per second to our servers, and it would just say 200, okay, thank you, and it would put it on a Kafka bus. And this allowed us to just handle, well, to not lose any events anymore that were sent from a client. Because if you're offline, then you will not notice that the event will be lost. So the new challenge that actually arrived here was service discovery. Because every time we would deploy a new collector, we would have to update our load balancer. And if you still are doing that manually, it's quite tedious. So actually this is also the time where we started to use Docker as a tool to ship or to actually deploy our software. So every application would be put in a Docker container, also the Spring Boot monolith, and would be deployed like that. So MongoDB logging problem. Well, we found Elasticsearch quite nice for log searching and all these things. So we said and also analytics. So I thought like, okay, then we're going to also use it for all our statistics query. And so, for example, how many people are watching the product the last 15 minutes, or how many people have bought a specific product the last 30 minutes, or 30 hours, or no, 30 days. So those are quite ad hoc questions that actually the system requires to answer to make sure that you can show a promotion saying, okay, 15 people have bought this product last month. But that added a new challenge, and I will come back to that later also, and that's called Elasticsearch. And another thing was we started to use a different data store for basically key value collections that are for a key value pair. So every visitor had a unique identifier, and we would store the whole visitor object as just a MongoDB document. But if then we want to scan this list to make some aggregations on what the properties of the visitors were, that was not really possible. So basically we switched to Cassandra for our collections that were bigger than 100,000 rows. That was the key takeaway. So we still are using now MongoDB for basically our counting. So every user that can log in, every account, every configuration, all the messages that are sent to the users, those are all still stored in Mongo. And I think it's a very nice database for that, because it allows you it's not a relational database, but within the document it allows for, basically just JSON relationships. So with Cassandra, we also found a new challenge, and that's actually, we have way too many services now, so we need more monitoring in order to see what's going wrong, because still you cannot log into every server to see use the top or the htop to see what is using the most CPU. You need more information there. No? With this button? Yes. So then we came to this huge pain of deployments and actually restarts. So back then, Mesos and Marathon were quite popular. Actually, Mantle was a project from Cisco Labs, I think, or Container Solutions also here, that actually set up quite easy way to set up Mesos. So who of the audience doesn't know what Mesos is here? Okay, cool. So Mesos is, you can see look at Mesos as it's being a single server, but then a whole data center is a single server. So you could talk to it as being a single server, but automatically under the hood, Mesos would distribute your application to various servers. So how it works is actually that there is a Mesos master, and that runs in high availability mode. And on top of Mesos master, you run certain frameworks, like Marathon is a framework for deploying long-running applications. You also have cron-like jobs you can schedule. And on each node, there is a Mesos agent running. And the Mesos agents actually do the work. So in the end, you can look at Mesos master and see that you have like 100 core, 500 gigabytes, many terabytes machine where you can run jobs on. So instead of doing manual deployments using CLI, you would actually post a JSON Marathon file to the Mesos master or to the Marathon process, just using a put, which would then find place or find a room in the data center or in the data service to deploy it. So you can set up certain demands you need. So for example, the collector, we run 3 instances of it. It requires 2 CPUs, 2024 megabytes of memory. It runs in a Docker container, and actually the Docker container is Crobox/collector/version, whatever version the continuous integration delivers. And the nice thing is about Marathon is that it also provides health checks. So within your application, you have certain things you want to confirm, right? Can I still connect to Kafka? Is my memory not too high? All these things your application or your service you want to deploy knows about, but Marathon doesn't have any clue of it. So what you can do, or what's recommended then, is to just expose a /health endpoint, or you can name it you can give it any name, and you have to configure it then in Marathon. And you can set up an interval and a timeout, and whenever this timeout fails, Marathon will actually kill or try to stop that instance first. If it cannot stop it, it will kill it. And then it will restart a new instance on another node somewhere in the cluster, so that the service becomes healthy again. This allowed us actually to very easily deploy new services without thinking about, do I need to provision a new server for that, and what are the requirements of the service? No, we just added the server, installed Mesos agent on it, and then that capacity was added to our pool of resources. So Mesos and also all the other services came with a new challenge, and that's service discovery. So because Mesos decides where to deploy the collector, you don't know where it is, right? You have to somehow figure it out, or the load balancer has to figure it out. So actually, we choose console as our go-to tool for service discovery. So every time we would register also a database, we would add an entry to the console agent that would say, okay, I'm this database, I have this address. So for example, mongodb.service.console. And every service inside our cluster would actually communicate with mongodb.service.console without knowing its physical location. So that's basically what service discovery is. Next to console, actually HashiCorp, which is the creator of console, also provides console template. And this is, I think, a really nice way to create configuration files, dynamic configuration files based on your service discovery. So actually we're still using Nginx, we're still using it. And we use console template to generate our load balancer configuration. So if there is like an event coming in for the /event endpoint, we will route it to the collector.service.console. And automatically, because collector.service.console points to one of the 3 instances of our collector service, the route is connected and will continue. But it's not only just that endpoint, it's actually every single domain name. So the Crobox.com website will actually route to the website service. The app.crobox, the management dashboard will go to the app.service.console. The API will go to the API. And this way, with service discovery, we would actually solve the problem of not be able to find a certain service anymore. So the last magic piece it's not magic, but last piece we put in and we found actually while developing or while making this prototype with Mesos is the Mesos console bridge. So whenever there was a new service registered in Mesos with the name, like the collector, it would automatically put that service in console so that the rest of the cluster could also figure it out. So next thing is monitoring. So if you have all these different services, you want to figure out what's going on. And especially you want to look at a relationship between metrics of like CPU, memory, databases, garbage collection times, anything you can think of that is a metric that could be of value. There are a lot of already off-the-shelf solutions like New Relic, Datadog. They all have these things. But since we were also switching to Scala and Akka, those tools were very suitable into monitoring traditional thread-based JVM applications like Tomcat, right, where there's a lot of thread, and not so severe in asynchronous applications, and also not so in adding support for Node.js or other types of small services which would run. So actually back then we also found out that Prometheus was open sourced by SoundCloud. And Prometheus is like an open source metrics and alerting monitor solution. So it works the other way around. So normally, you have 2 different ways to monitor your infrastructure. One is push-based, so every service pushes out the metrics to a certain endpoint. And the other one is pull-based. So you will pull out the metrics from your services whenever the metric service is comfortable in doing that. So Prometheus is actually a pull-based system which checks every 10 seconds all the different services and then will pull out the statistics of all the last 10 seconds basically, and then we'll put that in a key value, not a key value, a time series database. where you can build it up. So since we were using a lot of JVM-based software, we also found Kamon, which allows us for metric recording. So you can have gauges, histograms, all these things to get some statistics. And actually, how would you then visualize all these things? Well, that would be Grafana for us. I think it's a really nice. Grafana is one of the best open source dashboarding tools I think that's out there. So at the end of this, we would now be at a server or a cluster park which looks like this. So on the right, we have our databases: Elasticsearch, Cassandra, MongoDB, and Kafka. Those are not managed by Mesos, so we just install them on separate machines or on the same machine that Mesos would run, but then reserve a certain resource space. We had three Mesos master or three master servers basically, which would run Mesos master, Marathon, console servers. So that's like the orchestration thing, Zookeeper, that's a requirement for Mesos. We would have like 2 or 3 servers which were used for monitoring logging, so that would have a separate Elasticsearch for Graylog. It would have the Kibana the Logstash endpoint, Prometheus, Grafana, and some Kamon tools. And then we would have we started with 2 or 3, but then we now scaled up to I think 18 nodes. So just server workers, right, or worker servers or agents. So that would contain a base layer, which is required to run Marathon or Mesos. So that would contain Docker, Mesos, Logstash, console, and a cAdvisor. That's like a monitoring tool, but also possibly other. Well, that's mostly what's required on every server. And then actually Mesos would schedule each individual service on a certain node. And actually our Nginx load balancers on the left is then automatically configured to pick up the services configured at their endpoints. So how does our monitoring and logging look like in real life? It's actually a bit like this. So this is a screenshot of Graylog. And actually, we started to use Akka more, so you can actually see that we have 3 nodes now, which registered all 3 the members up events. So we had one central place where all our events or all our logs would come together. You could actually filter more on like application or source or do ad hoc searches. And this is a screenshot of Grafana. And this specific example is, I think it's Cassandra client latency. So it's the latency that the clients have when reading and writing of it. And we have like now, I think, hundreds of different metrics like node CPU, but also JVM internal stuff, which is exposed, Docker containers, how many containers are running, how healthy is the Mesos cluster, are there any things failing there? So this is where we went to. So now, actually, that started like the last year, halfway or beginning last year. We could easily split out all our server or our monolith server. So instead of just, and actually I think it went pretty quickly because we did see the bottleneck. So when to split up a monolith is I think it's not a difficult question. You need to split up a monolith if it's a certain part of your monolith requires way more resources than the other parts. So in our case, we had 3 main parts. One was the collector part, that was like event collection. Another part was the public API part. So actually that's the part where the website of the customer and the visitors of the website of the customer are requesting to our service, like, hey, give me a promotion for this product. What do I need to show now? Is it like almost out of stock, or is it 5 people are watching this product right now? It would receive way more load than actually our admin API. And also our admin API needs to be behind like authentication and authorization. So that's basically the first things how we split it up. But after that, we also saw again that the public API was having different parts. So we keep statistics about products. So each individual product is having counters about how many people are watching the product. But also each visitor has certain statistics, like how many pages has the visitor viewed? Is this the returning visitor or not? So we actually also split it up, this public API part, into multiple other services again that would now be able to deploy separately. And since we had this base layer ready with all the monitoring, the logging, and the Mesos infrastructure, it wasn't, it didn't cost any extra, right? We just created yet another Docker image. We created another marathon file. We posted the marathon file, and then automatically everything would come up. Well, that's the ideal story, of course, but I hope you get the point. So this way, we also set up a lot of auxiliary services. So we set up Apache Zeppelin. It's like a data science analytic notebook tool. Actually, next door there's talk about Jupyter. It's a similar like tool. But also services like better device detection, geo-IP lookup. We actually now are building a Webpack compiler that compiles the JavaScript that's run on the website dynamically, and that's actually a Node.js service. So we're starting to become a polyglot programming services. So last thing is challenge is Elasticsearch. So it really likes resources. At one point, we actually half of our server park was used by Elasticsearch. And we figured out, I think we used it wrong because we use it for aggregations. So we asked the question to Elasticsearch, give me all the how many unique visitors you have for each product for the last 20 days for a specific customer. So actually that uses aggregations, and Elasticsearch is built for search, but not really for aggregations, because it does estimations. It has, of course, circuit breakers, and it does an estimations on how much memory would this query take if I would execute it, but it's an estimate. So what we found out the hard way is actually that a single query could, out of memory, one node, and that would have a cascading effect on the other node, which would also go down then, and the other node, and then in the end, the whole cluster was unresponsive. So queries we asked Elasticsearch was, give me the unique profiles or the unique visitors for the last 30 days, but also give me how many people have visited this product the last 10 minutes. And that actually, the response times really varied from like a few milliseconds into multiple seconds, even like 10 plus milliseconds or 10 plus seconds, which is, I found it quite unreliable. And actually, it really likes resources. So, I already said that, no. So actually, we could not keep more than 3 months of data in our system, because then it would take more than 4 terabytes. And actually, well, we could add more nodes to it, but I had a feeling that if we would add more nodes to it, it would add us a month extra, but not that much. And the main reason why it's so much data is actually that we had to denormalize a lot of our data, because the way you query Elasticsearch is that you cannot do joins, or you cannot do any interesting relationships between it. So you have to put everything in the document you want to query. And actually, for our statistics service also and insight service, that was quite painful. So actually, last summer we started working on ClickHouse. And I found ClickHouse through a colleague who's actually Russian, so maybe that's the thing. But ClickHouse is made by Yandex. Yandex is, it has the second biggest, or after Google Analytics, it has Metrica, which is it's the second analytical tool actually on the internet. And ClickHouse, they open source ClickHouse, and it's a column-oriented database capable of real-time generating analytics data reports and queries. And we figured it out that if we would put our 3 months of data in ClickHouse, our click events and our view events and add to cart events, basically, it would only take, 100 gigabytes instead of 3 terabytes. That's pretty cool. And actually, we could write SQL queries, which was also really nice, because now we could just express ourselves saying, I want to select all the product IDs, and I want to get the unique profile IDs as value from the product events where the date is larger than like the beginning of the month, and the event type is bought. So I want give me from all the products, all the bought events, so I can use that to get a ranking of this information, actually show that information back to my users, how many people have bought this, or if this is a product that is popularly bought. So that really helps. So to get to the conclusion, actually, is like, in order to grow from a small monolithic system, I think, to microservices, it's essential to get your base infrastructure ready. So that means you need some kind of service or container orchestration, like Mesos, Kubernetes, or, well, there has been a lot of presentation, of course, on this conference about it. I think also a very strict requirement is to have aggregated logging or centralized logging, where you actually can see on one place, you log in on one place, and on that place you actually can figure out what's going on in your system. Monitoring. Basically, everything you can monitor, be it CPU, be it number of file logs, be it network, be it JMX memory, or garbage collection times, or any relationship you can put from multiple services together, right, to get some more insights. Because if you know that something happened and that's at point X, you can actually look at all your statistics, seeing, hey, what are the anomalies here, and what might have caused this latency spike, or what have caused this outage. And actually use a database that fits the use case. So we tried quite some databases. We're very happy with Cassandra. I think that has proved to be like the main key value store for us, that stores basically all our data. And also ClickHouse, I'm really amazed by the performance it delivers us. So to give you an example of when we switched from ClickHouse to, when we switched from Elasticsearch to ClickHouse, actually our 95 response time went down from 4.5 seconds to 300 milliseconds. So that was pretty impressive also for ourselves. That's it. Thank you. Any questions?
Thank you for your talk. What do you use as your source of truth for your data? Is that Cassandra or Kafka? Or?
Well, our real source of truth is Kafka. So basically I didn't tell that in the talk, but every event that is generated is put on Kafka, and certain topics on Kafka are backed up actually by using Secure. That was also in the slides actually. So Secure backs up your Kafka topics to S3 to store it as just basically files. So that's a single point of truth, which we also use again to develop new services, right, and to reiterate over it. So we read from Kafka to get to build up the statistic database. And actually the Elasticsearch and ClickHouse databases are also ingesting data using a replicator from Kafka. So everything is put in Kafka and that's then read. So another single point of our source of truth is also Cassandra to store our basically our profile information for each unique visitor.
Thank you.
Hi, my name is Marcus. I have questions. Since I think you have a client-based solutions, meaning that you put a JavaScript in your client side.
Mm-hmm.
How do you maintain the configurations? I believe like different clients have different requirements. How do you maintain the config?
Yeah. So that's mainly the admin part, and I didn't really talk about that for now, because it can hold a whole different discussion about it. So we generate a unique JavaScript tag per customer or per client, and actually our configuration that's configurable to our dashboard or our admin system can actually configure what functionality is connected to what part of the website. So we have like multiple things like triggers, events, extractors. So each customer gets this base layer that connects the JavaScript to their website, and then we can actually, if don't tell it, but if you put a JavaScript tag in a website, you get the Trojan horse in there, right? So you can do basically anything. You could just redirect it to other websites, or inject advertisements, or even do Bitcoin mining, I think. Maybe we should try that. Like no, but yeah. So we are configuring this JavaScript through our system, and actually recently we moved into ECMAScript 6 and using Webpack compiler to use imports to actually configure what is injected in the JavaScript based on the configuration of the customer. So if it doesn't use like this notification part, then it will not be included in JavaScript. And this way, it's configurable per customer. Does that answer your question? Otherwise, we can also talk afterwards about it. That's. Any more questions? Yeah.
Hi, hello. You showed 3 monitoring tools, but it wasn't clear which one you actually use. Are you using all 3 of them?
Yes. So they are connected. So Kmon is a tool that runs with your JVM to gather statistics about whatever you configure it to collect statistics about. So we use it to count how many active sessions there are in the system, how many active products there are in the system, what's the request response rate, right, or request response time. That is exposed through an endpoint / metrics normally. And actually Prometheus scrapes every service that's registered to Prometheus with these metrics. So Prometheus is like the database that stores time series data of all these metrics and provides you a search interface to that. And then Grafana is actually a visualization and dashboarding tool that can visualize this data that's stored in Prometheus.
Where's Camels in that story?
Kmon runs on the JVM itself. So it runs with the JVM. So it's like a Java library which you run with your JVM and which exposes the metrics. But Kmon it's not specifically built for Prometheus. You also have a lot of other connectors to like Datadog or doing other third-party monitoring solutions to basically get your JVM statistics like garbage collection and request response times. Yeah, you can also define your own metrics there, right? So you also for business logic you can define certain metrics like how many cache miss, cache hit ratio, all these statistics you want to know, and you have a distributed system. You want to centralize it, so that's where this Kmon tool comes in. And Prometheus is the database behind it, or Prometheus is storing the metrics for a certain time. Okay. Over there.
Hi. I'm really impressed by the diversity of your IT landscape. And I think you managed in a very short time to progress from a monolithical application to what you achieved now. And I was curious how much workforce was it necessary to do that?
So in total, I think it took us, it's 1 FTE for 3 months that to build up all this Mesos and Marathon stuff, but it was also growing into it a bit. And it requires actually, well, I built a lot of it, and it requires quite some knowledge about networking, about systems. And also, if now would go, so we use also Zookeeper, right? And we just run it as a Docker container. Stack Overflow is your friend there, but if nothing breaks there and it keeps running and we have our monitoring there and our backups, it works, right? But if it would really break down, so I think that's also the privilege we can afford as a startup, that if stuff breaks down, we can look for an alternative and try to restart it and then fix it or reset it. If you have really that's the young age of the startup. If we're down, well, we don't try to be down, but if we're down for an hour, that's so. We configured we programmed our system so that actually our customers would not be affected when we had downtime. But that was more in the beginning. Actually, I think last 6-7 months we had almost no downtime, maybe 5 minutes, or because the deployment didn't go exactly as we wanted, or so. So yeah, it's. I'm not sure how much man time it would, or how much time it would actually take. But for us, it's something that we growed into, and we had time because otherwise we would lose time on on fixing it, right? Just putting out fires all the time it's either that or just building something from the ground up. But the Mantle project, and I don't know if it's still there, but Container Solutions created Mantle with explanation how to get bootstrapped with Ansible and getting everything up and running. That really helped us back then in getting this environment there. But if you would start now with like greenfield, or you have to pick a solution, I might have chosen for Kubernetes, because the last 1.5 years it seems to be going faster, and especially also the hosted solution from Google looks pretty nice. But yeah, that's all the choices you have, right? Okay, that's it. Thank you.